Hello everyone, I'm Xiao Gang. Okay, now let's write our DS this time. We go to multigame. This is also a clean third-person template project. We only added the target, Maohai. We add a game instance here. We need to add a game instance, like this. We create this game instance through the editor. Okay, we failed to start just now because we selected the wrong one. We selected server. We need to use this editor to start, to create a game instance. Because if you start it directly here, it hasn't cooked the assets. You cannot simply start a server in this. Then you can achieve it through some methods, but we don't recommend doing it this way either. Now we have started it up. Let's add a class under general. This class should inherit from GameInstance. Just inherit from it. And we'll name it... Hey, why did it become a subsystem? Did I select the wrong option? Right, let's check again. It should be GameInstance, not GameInstance subsystem. It should be this one. We don't need to create another subsystem. We want to use GameInstance. It should be this name, Gimit. MuteGameGameInstance. Let's remember this name. Then let's put it under this directory. Let's not bother with subfolders anymore. Okay, good. It has been created now. It's just that we haven't refreshed it yet on our end. Okay, then on our end, we need to close this editor. Okay, let's wait patiently for it. Okay, it has arrived now. Then let's close this card. Then let's reload. After we finish reloading, we have a Gamma instance. Then let's open the Gamma instance class. The Gamma instance class. Let's go into its input keys, and it has a method that we can override. This method is init. That is to say, when we initialize, we need to execute, so we need to override this method, copy this over, and then this method should be a let me check. Init is a public method. Okay. Okay, let's remove the part in front. Then we need to add a worldwide. Okay. Then we also have a shutdown method here. Let's copy the shutdown method over as well, because we have a beginning and an end here. We want this to properly release some resources. So we have a lower gear here. I clicked the wrong one. Never mind. Before we continue writing below, let's go back to our previous project. Because in our previous project, it seems we missed something in our new tile manage section. In this game mode, we actually need to, in our disk, and in the program on our player side, also do these things, and when we underplay, we should actually remove these proxies. Remove them. It is bound to us. So first, we need to remove it first. This is for our dynamic multi-wave, because, of course, it's fine if you don't remove it. Since this object is already gone, it won't actually reflect over, but removing it is a good habit. Sometimes I forget this. But as long as everyone knows that this step is quite important, it's fine. Of course, there should be no problem compiling here. Okay, let's wait for it to finish compiling. You see, it's just compiling these few files. Okay, the compilation is done. We'll just leave it alone. Go back to our GameMode place, and actually what we need to do is to import some related things from our client subsystem. And here we definitely have a method that needs to call the parent class. So let's call this super first to avoid missing anything that might cause issue with the engine's workflow after we finish modifying the book. Next, first, let's include the header file. For this header file, we definitely need to get our client subsystem, and we are still missing some types here. Let's copy these types over. What is this type? It is actually this type. It was on our DS earlier. It shouldn't be that. It's in our project. This type, this mute type, we need to copy these two files over here because we need some basic data defined in them. Okay, then we put it here. Good. Okay, now let's refresh the project. This part is a bit tricky. Let's reload it. After we finish refreshing, we can include our type here because we will need to parse the data inside later. After writing it, we go here to get our client subsystem. This is our dedicated place for sending messages. There's no need to get GameInstance here because we ourselves are the GameInstance. So we directly go through the GameInstance to get to the subsystem. Then we add 4 bindings here. As for the 4 methods of these 4 bindings, we just bind them to our GameInstance. Okay, now we don't have this method yet. We'll write it later. Then here we will connect our client with our server card inside the WSM. It's port 9033, right? We need to save the ID here. We will use this ID later for sending messages, so we need to save it. Okay, after saving it, we will write these 4 methods. These 4 methods are relatively simple. Since we've written them before, we'll just copy them over. Remember to hook up the U function signal. You can click into it to see its function signature. Its function signature is right here. You can see they are all relatively simple. Yes, we wrote these function signatures by referencing this with ku. Then we will create these 4 methods. Okay. Then the creation is complete. After that, we can, in our next step, we definitely need to remove this method, right? Oh, because we have bound it. We need to shut it down now. We definitely need to remove it to prevent any other information from coming in. Then after the shutdown is complete, we will disconnect all of these links. In this place, we need to get the client subject effort again. So here, we close all the links. At this point, we enter the actual process of this next step. Okay, good. Now, the key point is this method of how to write it. Obviously, we need to, when the connection is a success, whether we are the player or our DS, we need to actively send a message to let it know, meaning to let it know what our identity is. So if we are here, we are on the client side. We can do it this way. If we are a client, then we might not be able to get this light mode thing. It might not be available because this might require only ATA has this light mode. So here we first get word, then we get this light mode. Of course, this is actually a bit risky because this get word, it might sometimes be a null pointer. So this part is a bit dangerous. We probably shouldn't write it this way. We can write it this way. That is if we can check, that is, we can control it through red. So here, we control it through red. We should not use getWorld because getWorld might sometimes be empty. It might cause us to be unable to properly initialize. So if we are on the server, we will do nothing for now. Here we use else. If we are not on this server, it means it is another character. Then we need to perform an initialization of the information here. So how do we do it? Let's not write it this way for now. Don't write it this way for now. So to prove that we are currently on this client, then when we are on the client, we need to prepare some information. First of all, we need to prepare a request message. And this is our struct. We need to simply fill in the information in the struct. We should have this here. This information is it. We haven't written a response to this request yet, but we have written this part now. Let's just write it down. Okay, in this place, we set its deduction value to 0. Then we define each sentence as this. That is to say, please do not. Is this place requesting DS? Instead, it is requesting this player's role. Right. Then we take this. This is the first level information. First level information. And here is, we are going to prepare its data structure. The data structure as the second level information. So obviously the second level information mainly includes the username. We will write a template for the username first. You can expand it on your own later. Then we take the second level information, convert it into such a God level entity. Then we just copy it onto this first level information. So here we are missing the God level module. Therefore, we need to import the God level module. We place it here. Okay, once that is done, we first include the header file. Good. That should work. So this is what the client needs to do. It is what the client needs to do. After we have prepared this, we can then this first level data and got it done. This is the first level data. Then after finishing it, we need to get our client task P. That is we. So here we send it to our server. Here we do an initialization. The ID we send actually uses this ID to send. Then this client go do this initialization. But on our server now, our DSM hasn't written its response yet. Let's ignore it for now. We'll just leave it here. Next, let's handle this part. This part will be a bit more troublesome because here we need to go through an extra layer. We need to go into the game mode to handle it. So here we need to prepare a proxy. As for this proxy, we can just make it a dynamic proxy. Okay, so for this proxy, we call 1 over. We can just use one with 2 parameters. That's it. We'll set up a forwarding here. Okay, let's put it here. Okay, as for these 2 forwardings, they are actually FDEY. Then we drag this information over here. As for its name, we'll call it. Let me change it. This is at the plug level. We need to change it to these. This part switch to our project level. This must be designed this way to be more reasonable. Then after this proxy, we will make an instance of it. Once we have it, we need to expose it to Blueprint. We can just write it directly in the downstream. When it connects successfully, we will just execute it. Let's first make sure here. This cannot be named this way. Because this name duplicates with that name, let's give it a different name. Applying this name should work. Okay, here we give it a broadcast event. We can't compile yet. Let's compile first. Let's compile it first. It seems it didn't recognize that yet earlier. So let's compile it first. Okay, so we have this thing here. We will trigger this on our DS on the server. Only then will we trigger this. Let's check. Its broadcast should be broadcast. This place is broadcast. Okay. Of course, this place might not be able to add vision. Let's comment it out first. Comment it out and compile. Make sure this compiles successfully. Forgot to write a semicolon here. Still getting an error here. In cases like this, if you compile it and get an error, it's easier to handle. Just cancel it and it'll be fine. Okay, it should be compiling successfully on our end. I forgot to comment this out for you here. Also need to comment this out. Okay, let's first make sure this compiles successfully. Okay. Then we can just put it back in. Okay. After doing this, we go to our game mode. We'll ignore the rest of this information for now. Let's first ensure this initialization can be sent over. Let's go to our game mode here. Then we find our begin play method. We need to override it. Then we mainly need to override these two methods. These two methods. Okay. Let's create these two methods. First, we still need to call these two methods of the parent class. Because if you don't call the parent class, there will be issues here. Okay. After calling the parent class, what then? We need to bind that dynamic multicast thing. So how do we do it? We should be able to get GameInstance here. This will definitely succeed. Here we will get a pointer to GameInstance. Actually, we'd better. We'll just convert it directly to our side. First, let's include our GameInstance header file. We will definitely need this type. So let's include this type as well. Okay, so when we get the GameInstance like this, we need to cast our own thing. Only then can we access the element we defined inside it. In this case, let's just cast it. We'll use a pointer to receive it. Okay. Here we need to find this. This should be xt. It should be this one. Here we might need to make this delegate public. So we put it here. Okay, after putting it here, we can call it in our game mode. Let's paste it here. It didn't recognize it, no way around it. Then we add it here. Then we dynamic. Then we definitely need to bind this method. And as for this method, we haven't written it yet. Let's write it first. This method should be called put it here. That is, when we successfully connect, this method will be triggered. Then this method is 2 characters. Guide. We just need to copy the dynamic delegate he declared over. Okay. Now let's create the implementation of this method. Good. After creating it, we place this method in this position. Good. Now we have bound it. Since we have a binding, we definitely need to unbind it. So when we underplay here, we need to remove this binding. Good. Here we will receive a message like connect success. So at this point, we need to send some information to then we need to check here. We only do this work on the DS because we are not covering the LS here, because the LS would interfere with our learning. After you finish learning this Ds, you can directly handle it and it will work. We can send it directly like this. We can do it without going through this. What's it called? GameInstance. We can also send it. Then we can encapsulate a method inside GameInstance. then posting it in GameInstance is also acceptable. So we can just post it directly here. This doesn't really matter. Under normal circumstances, you should write all this communication here. Write a raw message here. Since we didn't write it here, it should still be fine. And if we are on a dedicated server, first, need to prepare the information we want to send. Obviously, this information, first of all, this code must be equal to 0, right? It should be this. It used to be a small f. This is not quite right. This should be the recruit's message. And then for the type of this recruit's message, it initializes a character of the DSM type. Okay, then it needs to prepare some 2G data. As for the 2G data, it needs a bit more. We need to retrieve it for him. So first, for this level name, we can use the GameMode method to expose this property. We need to expose it like this, because we can use various methods to provide it through different game modes. We might have many DS maps. So we can specify it through blueprint. Then for different maps, we might have a GUID or something. We can assign a GUID. This doesn't affect anything. These are all reserved fields. They're just placed here. So everyone knows you can do it this way. But currently, we won't dig deeper into these fields or perform a real verification. On these fields, we won't bother with any of that. The key point is the DS port. The DS port needs to be obtained through our serial subsystem. There is a method here for us to retrieve it. Of course, you can write it this way. It's fine. It's fine too. Okay, after we get it, we copy the DS port into it. This way, our secondary service information is ready. Then next, we convert the struct into the actual data. Okay, here we need to include JSON. Actually, if JSON is used frequently, we can directly put it into our struct. For this saving, we can copy one from here. Here. Okay, good. With this saving our 2G data, this information is ready. We export it as a string. Then we complete an assignment. Right. Then this must be the recruit messaging. Good. After the copy is done, then we can send it here. First, we definitely need to take the struct directly like this and convert it again. Singrids this struct into the corresponding struct data. Then we can send it directly through climb subsystem here, no problem. We can also send it through GameInstance, that's also fine. But you'd better have a unified system for sending and receiving messages. So we actually need to take this whole chunk and put it below, down here. Because we only do this on the DS, the speed up work on the client side. If it enters this map, it doesn't need to do this kind of work. Okay, so after we do this in our GameInstance right here, this message will receive this information. It will receive a piece of information that has already been speed optimized. Okay, let's stop here for now, then we'll compile it. Let's not rush to write further, because this part is already a bit confusing. Let's see if there's a compilation error. Let's see what went wrong. Here we missed an address of operator because it's taking the address of this function. Let's check. There's still an error here. Probably we missed something somewhere else. Obviously, we missed it here below as well. Okay, let's compile it again. Okay, then in the next episode, we can do a brief test